Hello friends, so here is another question on electric dipole parameter. So it is given that calculate the electric field due to an electric dipole of length 10 centimeter having charges of 1 microcoulomb at an equatorial point 12 centimeter from the center of the dipole. Okay, so first let us draw the diagram for it. So here we have an electric dipole of charge 1 microcoulomb and plus 1 microcoulomb, minus 1 plus 1 microcoulomb on the two extreme ends. The length of the dipole, that is equal to 2a equals to 10 centimeters. Okay, this, and from the midpoint or the center of the dipole we have to find the electric field at a point here, let's say, which is at a distance of 12 centimeters. So this is the equatorial line. So the formula associated with this is, along the equatorial line the electric field is equal to 1 by 4 pi epsilon 0 p vector modulus, that is the magnitude of the dipole moment, divided by x square plus a square to the power 3 by 2. We have already derived this expression, so please check the electricity and magnetism playlist and watch the videos related to electric field due to dipole along the axial and equatorial lines. There we have derived the whole thing. So first, here the dipole moment, that is equal to q into 2a. Okay, so either charge, that is 1 into 10 to the power minus 6 multiplied with the dipole length, that is equal to 10 into 10 to the power minus 2. So we will be substituting here 1 by 4 pi epsilon 0, that is equal to 9 into 10 to the power 9. Here we are using epsilon 0, that is absolute permittivity, because nothing has been mentioned here whether it is placed in any other medium, so we'll consider free space air. So 1 by 4 pi epsilon 0, that is equal to 9 into 10 to the power 9. Okay, so then this much multiplied with this 1 into 10 to the power minus 6 into 10 into 10 to the power minus 2 by x square, x 12 centimeter, that is equal to 0.12 meter, x square plus a square. A is equal to 5 centimeter, as 2a is equal to 10 centimeter, the dipole length, that implies a is equal to 5 centimeter, which is equal to 0.05 meter, x square plus a square to the power 3 by 2. So if we calculate the result, it is coming around 4.096 into 10 to the power 5 Newton per coulomb. That is the electric field along the equatorial line for this question. Okay, so this is the result. So you have to remember the formulas. Okay, you have to be thorough with these formulas. So here is another question on electric dipole parameters. So it is given that 2 point charges, each of 5 microcoulomb but opposite in sign, are placed 4 centimeter apart. Calculate the electric field intensity at a point distant 4 centimeter from the midpoint on the axial line of the dipole. Okay, so here we have two charges. One is -5 microcoulomb and the other is +5 microcoulomb. They are placed 4 centimeter apart. So the separation gap, that is equal to 4 centimeters. Okay, this is the midpoint of the dipole. We have to find the electric field intensity here at this point, which is at a distance of 4 centimeters from the midpoint of the dipole. Okay, at this point P. So this is along the axial line. So here this distance, this is called as x. X is equal to 4 centimeter. The dipole length 2a is equal to 4 centimeter. That implies a is equal to 2 centimeter, which is equal to 0.02 meter, and this is 0.04 meters. So along the axial line of the dipole, the expression for electric field intensity, that is equal to 1 by 4 pi epsilon 0 2 p vector x by x square minus a square square. This is the expression of electric field along the axial line. So here we will be substituting the values. 1 by 4 pi epsilon 0, that is equal to 9 into 10 to the power 9. Okay, then here P is equal to the dipole moment, which is equal to Q into 2a, which is equal to either charge value 5 into 10 to the power minus 6 into 2a, which is equal to how much? 4 into 10 to the power minus 2. So here it is equal to 5 into 10 to the power minus 6 into 4 into 10 to the power minus 2. Then this is P, then multiplied with again 2 into this much, this is P. Then x is equal to 4 into again 10 to the power minus 2 or 0.04 by x square minus a square, 0.04 square minus 0.02 square whole square. Okay, so when we calculate it, it is coming around 9 to 10 to the power. It is coming around 10 to the power 8 Newton per coulomb. Okay, this is the electric field along the axial line of the dipole. So again, here the important thing is to remember the formulas of electric field intensity and all the other parameters. So I have derived the expression for electric field intensity for an electric dipole along the axial line. So you please check the video in the electricity and magnetism playlist. Okay,